Our universe is made of matter and energy. 85% of this matter is dark matter. The reason scientists call it this is not because it signals the end of their academic careers, but because we just can't see it at all. So if we can't see it, then how do we study it? Well, Albert Einstein saved us the trouble with his prediction of gravitational lensing, which states that anything with mass can bend the path of light. Imagine you were looking at two galaxies through a telescope. The mass in the blue galaxy would bend the light from the red galaxy. If you traced back the path of the light rays, you would see the red galaxy in these positions. The problem is, conventional dark matter models cannot explain the brightness or position of these images. So a new dark matter model was proposed, wave dark matter. It behaves like waves on a beach. When waves meet at the shore, they interfere with each other and produce complex patterns. In the same way, wave dark matter interferes at certain physical scales and produces these grainy-looking patterns, much like sand on a beach. I have carried out simulations using a supercomputer to study how these patterns influence what we see through our telescopes. Simulations are the only way to probe this area of astrophysics because we just can't create a galaxy in our labs. My research has shown that patterns like this can cause significant differences to the image, shape, position, and brightness. And they are in better agreement with observations. Apart from the fact that this lets scientists get better funding and research grants, why is this important? First, accurately knowing the position and properties of these images allows us to study distant, hence very young galaxies. And this, like time machines in sci-fi movies, lensing acts like a natural time machine and allows us to peer back into the past and study the early universe. This tells us how our universe was created and reached its current state. Secondly, this allows us to know what our universe is really made of at the fundamental level. And then, people can ask, what could dark matter possibly do in our everyday lives? I like to use this analogy. Humanity in its infancy was dramatically shaped by the discovery of fire. I like to think that dark matter would be the next ultimate discovery to propel humanity into an advanced civilization that is capable of expanding beyond Earth. Thank you.